Let's look at how to graph horizontal and vertical lines. So the way we can tell we have one of these special case lines is we only have one variable in our equation. And here's another example. It's only got one variable. Now you can memorize that y equals some number is going to be a horizontal line, or you can just fill in an xy table. And this equation is telling us no matter what, y has to be -3. So if I wanted to make an xy table, I would just put a -3 everywhere that I see y. So no matter what, my y is a -3. And that means I can choose my other variables. So if I chose a 0 for my x, my y has to be -3. If I chose 2 for my x, y has to be -3. And I can choose a 4, and same thing, y has to be a -3. Now when I go to graph that 0, -3, I go 0 in the x direction, 1, 2, 3 in the y direction, 2 in the x direction, and -3 in the y direction, and then 4 in the x direction, -3 in the y direction. When I actually make my line, you can see that it's a horizontal line. And that tells me that if I have a y and no x, that I am going to get a horizontal line, and in this case I drop down to -3 for the y part, and it'll go across there. Is it a function? If I put a vertical line anywhere on the graph, yes, it'll pass the vertical line test, and therefore it is a function. The domain is, remember, the values for x, and remember I could pick anything I wanted for my x values, so anywhere across here there will be a corresponding y down here at -3. So my domain goes all the way from as far left as I can possibly go to as far right as I can possibly go, so -infinity to +infinity for my domain. And remember, the range is in the y direction, and for my y's I had to have a -3. And if I come here for my y's, I can look -infinity, no, until I get to -3. Yes, that one's included, but then nothing above, so I can see it both ways. Since I only have one value, I make it a set of -3 only. I'll give you a second to figure out the next one. X equals 2. So in the same way that I worked the problem above, I can work this one, and I know that no matter what, my x has to be 2. I can either memorize that if I only have an x and no y, that I'm going to have a vertical line, or I can plug in numbers for my xy table. So I'll show you the xy table just so you can use that as a backup. No matter what, my x has to be 2, so I put in my 2 for any of the x values, and that means that my y values I get to choose. I can do the 0, 2, and 4 again, and then use those ordered pairs, 2, 0. So in the x direction I move a +2, and then nowhere in the y direction, that's 2, 0. And then for the next one, 2, 2. So I'll do 2 in the x direction, 2 in the y direction, and then 2, 4. So 2 in the x direction, 4 in the y direction. Now when I connect my points and make my line, I can see that I have a nice vertical line. And the first question is x equals 2 a function? Well, this is x equals 2. I can put a vertical line anywhere along here, no problem whatsoever. If I place my vertical line right here, however, it's going to intersect with my x equals 2 line an infinite number of times, because every point on the line is an intersection with this imaginary vertical line, and it's going to fail my vertical line test, and so it is not a function. So I would say no for is this a function. Now this is the only straight line that is not a function, the vertical lines. For the domain then, I'm looking at the x direction, and I can look at my xy table and see that all my x's have to be a 2, so I can put it in like this. Or I can look from my graph and look from negative infinity and see that there's nothing included all the way up until I get to the positive 2, and then beyond the positive 2 no values are used again. So just a 2 is used. My range, I can look at my y part on the xy table, and remember I could have chosen any values all the way down negative infinity. It would have had a 2 for the x value, all the way up to the positive infinity. So the range is negative infinity to positive infinity. Here's a special kind of graph, and it's absolute value functions. So I have a function that's an absolute value, and I need to figure out what does it look like on a graph. So I gave you several values to try, and we'll start off with the -3. So when I plug in a -3, it's in the x column, so I'm going to plug it into this equation for the x. So I'll have y equals absolute value of -3 minus 3 and absolute value. Now when you're working with absolute values, you calculate inside the absolute value first and come up with just a single number, and then apply the absolute value. So if I follow that, I will add -3 minus 3, and that gives me a -6, still in the absolute value bars, equals y. And then when I actually take the absolute value, I have a single number here now, so I can take the absolute value. The absolute value of -6 is a +6, so that will go here. Then for the next one, y equals -1 minus 3. That's going to give me the absolute value of -4. And then when I take the absolute value, it changes it to a +4. Now I can go along this way in the same manner. If I plug in a 1 here for the x, I have 1 minus 3, which is -2. Take the absolute value, and -2 turns to a +2. If I put a 3 in for x, 3 here, 3 minus 3 gives me 0. Take the absolute value, still 0. Put a 5 in. 5 minus 3 is 2. The absolute value of 2 stays 2. 7. 7 minus 3 is 4. Take the absolute value, and it's still a +4. 9. If I put 9 here, 9 minus 3 is 6. Take the absolute value of 6. It's still 6. And then I've got my xy table filled in. I can see -3, 1, 2, 3, and +6, -1, and +4, 1, and 2, 3, 0, 5, 2. Do you see the form starting to take shape? 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4. And 9 and 6. And now when I complete this with my lines, they are going to go on and on. If I continue to plot points, they would go on and on like this. And we should always have this characteristic V shape. So here it says absolute value equations always look like a V, because the absolute value won't let the second variable be negative. Remember up here when we plugged in the -3, we got a -6, but then the absolute value flipped it positive. And the same thing when we plugged in a -1, we got a -4, but the absolute value flipped it positive. So the absolute value made this part bend up. Alright, let's look at one more. This one you can try out. Graph. Y equals the absolute value of x. You can pause the video and try this one. Okay. I'd like to make an xy table. And for my x's, I can choose any numbers. I know that if I put 0 here, then I'll also get a 0 for my y. And that's an important value. because it's going to be this point here